Hello everyone, we are starting a free open lecture in our Discord. All our lectures are held weekly, without interruptions. If you, the viewer, want to ask questions and receive answers in an online format, join our lectures. You can find the link to Discord in our Telegram channel. To find out the schedule for the lectures, please join our Telegram channel kindly and stay updated with the latest information. And Bob Dated has a cake of the 11th type. So Alice Maximum was able to eat 4 cakes. That means Bob Pistolets had 7, 8, and 11. So yes, in this particular test scenario, that's how it turned out. Alice's specific task is to eat the cheapest cake that she hasn't tried before, ensuring she experiences a new flavor each time. Meanwhile, Bob's task is to cut the unique set of cakes as much as possible, which means he needs to focus on minimizing the variety of cakes available. And accordingly, how this can be done in terms of dynamics will revolve around Bob's strategic approach to cake cutting, considering factors such as cake size, shape, and distribution. This dynamic interaction between Alice and Bob's tasks creates an interesting challenge. Let's say that out of the cakes eaten, they have consumed a total of 4 cakes together. We divide this in half and round up, which will give us how much Alice Maximum has eaten. So, it's clear how much she has eaten. Bob Dated will eat only from these cakes, and he can still eat more. But with Bob Dated, the situation is, as always, in many ways more fascinating, intriguing, complex, and nuanced. For instance, imagine that we have already completed the process of going through the initial batch of cakes. In other words, this means that these cakes are currently being divided. First types such as second and third, fourth and fifth, and here we are at this type. And at the same time, Bob is one of those individual types with distinct and unique characteristics, while Alice Maximum carefully and meticulously removed the K types of delicious cakes from the selected assortment of diverse varieties and flavors. Accordingly, we need to find the cost of this event, that is, how minimal it can be, considering all possible expenses and savings.
Want to become a great programmer? Subscribe to our Telegram channel.
Bob carefully removed a variety of different types and varieties of cakes from the collection of Alice Maximum's assortment. Why indeed is the minimum one a cake? As if it matters how much time he took to do it, as long as the main thing is that he just ate it, and it was awesome. Firstly, this way, if we cut optimally, he will certainly be able to eat more. And secondly, initially we will have a matrix of m by m, where m is the number of original types of cakes, and everything will be filled with inf. And accordingly, our answer will be traversed through the last row. That is, where we have already eaten all types of cakes. We have tried everything. We need to see what the maximum is among these types, meaning we will go from the end in the maximum amount, how much he has eaten until the cell equals infinity. As soon as we encounter some definitely achievable egg cell not for infinity, it results in mi, where I is how much Bob has eaten. This will be the answer to how much Alice has eaten. TFs. At this initial stage, there are questions to start with. How do both eat delicious cakes? And who exactly benefits from eating them? How will we build the DP later? I will explain the idea from a game perspective for now. Is this perhaps unclear to any of you, or does anyone have a question? San, what about you? Is everything clear, or do you perhaps have a question? Maybe? Okay. Yes, let's continue. So, we find ourselves in the IK cell, where I is the number of types of cakes passed, and K is how many of them Bob has collected. We need to find the cost for this thing. So, accordingly, how can we, in order to effectively and efficiently achieve this goal, obtain it? We either discard the current type of cakes, which will have a discard cost of C ETH, where C represents the Ethereum cost associated with discarding these cakes, or we go back to see how much we have already accumulated in cost, which involves reviewing our previous expenditures and calculating the total amount spent so far. Initially, we pass to DP, which stands for dynamic programming, the option that we do not break the current type of cakes, TFSP, which is a strategic decision point in our process. Then we try to eat the it type of cakes for Bob. This will be our situation in DP, where we analyze the potential outcomes and benefits of consuming this specific type of cake for Bob, considering all possible scenarios and their implications. And -1k minus 1 plus c minus 1. And at the same time, this thing should be generally achievable. This means that it is achievable in a practical sense, and considering all factors involved in the process of achieving this goal. It is achievable in terms of cost, meaning that the total number of cakes eaten by Bob will be less than, while maintaining efficiency and effectiveness. Subtracting a from itself results in 0, as a minus a equals 0, which is a fundamental principle in mathematics. So, honestly, we need to count how much Alice has eaten from this. How much could she have eaten here? Well, in theory, it's just stupid and minus, like -1, because they are essentially eating. Sure, yes. Basically, essentially, they could even be divided in half. Well, let's see. By the way, it's interesting. I forgot this thing. That is, we need to, in total, how many cakes have been eaten here? This was actually an achievable situation. They ate together. And essentially speaking, this could be divided into two distinct parts by either rounding up or rounding down. In this context, this will give us the overall situation regarding the amount of how much Bob has eaten. If Bob ultimately ends up eating more than half of the cakes, which have been eaten in some unclear way, in totality and entirety. Well then, let's explore this further. Ideally, it should function like this. In the code, it's calculated as subtracting k. This calculation is essential for the system's correct operation. Right, that's the process. If we successfully manage to do this, and this is our Subarno, k is how much well, essentially it will be the same as dividing by 2 actually, because k cannot be essentially more than half. Literally, the process will function in the following manner. We begin by taking the total number of cakes that are available to us. From this total, we will subtract the number of cakes that have been consumed by both of us together. Additionally, we will also subtract the number of cakes that have been destroyed or rendered inedible, specifically in the context of Bob's actions. This calculation will ultimately provide us with a figure that represents the quantity of cakes that Alice has consumed. By carefully considering both the cakes eaten and those destroyed, we can accurately determine Alice's consumption. Here, we could actually divide by 2, but I'm not sure, and it would yield the same answer. Accordingly, what we have here is that we choose the minimum based on what was calculated before, and so from I1, K1 plus, beautiful, vibrant, and colorful flowers. In other words, that is, we have the option to either choose whether we completely destroy this type of cake for Bob or simply leave it unchanged, as it is based on the decisions made from what has been done for the initial first 8 types of cakes. And essentially, in essence, the whole game is that we take the most affordable and least expensive type for Alice, our main character, while Bob wants to eliminate and obliterate as many types as possible, as quickly as possible, in the shortest and most rapid moments of time. So, in the end, we end up filling in, navigating, and going through all of the various elements. When every single one of the types is completely eaten, we then proceed to locate and identify the very first element we happen to come across, starting from the end. This is where we find Bob, Smock, Stolka, and there are types of Tartovci, TFSP, and we subtract, resulting in Iminci. This is how many types of Tartovci, or SSI, Are there any questions or concerns regarding the solution we have provided for this problem? We have identified a specific type, and it is crucial to understand what this means. Could someone explain what this type signifies or represents in the context of the problem we are addressing? We have the first and past types of cakes, including a variety of delicious and different types of cakes available. How many of these different types of cakes has Bob approximately eaten in total, perhaps, would you say? And what lies inside? The number of pears that Alice has eaten? No. The number of cakes that Bob had to munch on to destroy that many types of cakes. Alice needs to eat one cake of each type. It's enough to eliminate them. A cake of this type must be eaten whole. So here he has 2 of type 11. He needs to eat this one and that one. Overall, it feels like in this particular task, Bob seems to eat significantly more cakes and goes first in line with Alice. This observation is indeed true. Are there any more questions? Right now, it currently shows how many cakes Bob has destroyed. And this is how many distinct types of items have been passed in total, and K is how many unique cakes Bob has completely eaten in entirety. Look, let's say, in this task, the final K is 2. What does that mean? 2 types of cakes in total, not 2. Actually, it was 3. What does this mean? He has completely eaten 3 types of cakes. He has fully eaten the 7, the 8, and the 11 completely. And what's inside? Inside is a 4, because in total he had to eat 4 cakes. That's how many cakes he ate, basically. That's what's inside. Yes. And how many types did he remove? Cakes. Yes. That's it. Thank you. So, well, I probably need to ask for the code right away. I'll show you. Something tells me that this will also be the case. TFSP. It takes a long time to code, so. What was actually happening in this thing? Yes, by the way, it only works on positives, if I'm not mistaken, right? Yes. Well, basically, what's the deal here? To begin with, we need to determine the total number of different types of cakes available. This involves identifying each unique type and then sorting these types in ascending order based on their characteristics or identifiers. As a result, we obtain a comprehensive list that includes all the types of cakes. Additionally, it is crucial to keep track of the quantity of each type within this sorted array. For instance, after sorting, we might end up with a sequence like 2, 3, 2, 3, 3, 5, 6, 7, 8, where each number represents a specific type of cake. Furthermore, we maintain an auxiliary array denoted as C, which records the count of each type. In this example, the array C would be structured as 1, 2, 2, 2, 1, 1, and 2, indicating the frequency of each cake type in the sorted list. This process ensures that we have a clear understanding of both the variety and the distribution of cakes, which is essential for any subsequent analysis or decision-making related to these items. By meticulously organizing and documenting this information, we can effectively manage and utilize the data for various purposes, such as inventory management, sales forecasting, or even culinary planning. In this sequence, what does this mean? We observe that the numbers are distributed as follows. Specifically, we have a total of 1 instance of the number 2, 2 instances of the number 3, 2 instances of the number 5, 2 instances of the number 6, 1 instance of the number 7, 1 instance of the number 8, and finally 2 instances of the number 11. In this way, we sorted by type and then recorded how many types there are in terms of their quantity in volume. This is this thing here. Next, we set the DP. Everything is filled with something mega fatty. It doesn't need to be particularly bold here. It's only 10.9. The starting value of 0.0 is equal to 0. That is when Bob ate nothing and Lisa ate nothing. Therefore, then in totality, Bob ate nothing. As a result, well then, the thing is simply launched purely according to the formula. That is, we essentially first navigate through the TFSP process, the value from the previous one, the number of various types of cakes that have been eaten. Then we try to eat our current different type. The price is stored in the date for how much Bob will eat it approximately in total for his consumption of food. We check that Bob certainly did not at all eat more than Alice. He indeed cannot do that. So we look at the minimum cost of what Bob ate, which involves calculating the least possible expense for the food items he consumed. And in the end, we get the maximum amount Bob could have eaten, considering all possible scenarios. Accordingly, we also get the minimum amount Alice received for the food. ensuring fairness in distribution. We iterate through each step meticulously and output the answer. That's basically it. So, here's the link I shared for further reference and detailed explanation. If you have any questions at all about the code, feel free to ask. It's not especially complicated. So, if there are no questions, then that's all for today. Thank you all for your attention.
Want to become a great programmer? Subscribe to our Telegram channel.